Hello everyone, welcome to the official YouTube channel Smart, and I am your chemistry educator for today. Today my topic will be, as you can see, it will be hydrogen bonding, and I am going to start with the application of hydrogen bonding first. Okay, what is the importance of hydrogen bonding over here? Now, what do I mean by the importance of hydrogen bonding? Am I going to talk about whether we have it in our DNA, RNAs or not? Whether we are using it in the solution, whether it's there in the water or not? No, that's not what I mean actually. I mean, what is the importance of hydrogen bonding in our exam? See, in this official YouTube channel of NSmart, we will only be focusing on the exam-based knowledge, right? So, as you can see over here, first, where are we gonna learn, where are we gonna come across this particular topic? Okay, so for example, first, if I talk about the chapter solutions. Solutions is the second chapter. It used to be the second chapter. Right now, it is the first chapter of physical chemistry after solid state, right? But now, anyway, in solutions, I guess you guys have seen the questions of Vant Hoff factor, right? I guess all of you are aware of the Vant Hoff factor question. So the questions where the I values are needed to be found out, correct? And in those kind of questions, I guess you have noticed that there are two types, which is association and dissociation, isn't it? Now, under the segment of association, you will come across hydrogen bonding. I will tell you in details how. I will show you the questions in the end of the video. So stick to the video till the end, because in the end we are solving these CBSE boards questions which has been coming, and I'm going to show you from hydrogen bonding this single topic. See, this is not a topic which is there in the book separately, but I am teaching you this because I'm going to submerge not only one chapter actually, I'm going to submerge 5 chapters over here. That's why this video is going to be very, very important for us. And in the end of this you will be solving questions with me. Those have been coming in the previous years of CBSE question papers, right? Now, the point is, you will be able to see that for 2025 itself, only for 2025, there were 5 questions which covered hydrogen bonding in it. So, I'm just going to tell you what all topics comes from hydrogen bonding. One is from solution chapter, there the Vant Hoff factor question where the association of the compounds are being discussed, carboxylic acid system. I'm going to talk about that. Second thing where we are going to come across hydrogen bonding is all the physical properties. All the physical properties. Physical properties of whom, guys? We are talking about physical properties of all the organic chemistry chapters. So, जितने भी organic chemistry के chapters हैं हमारे, वहाँ पे haloalkane, haloarenes को छोड़कर कोई भी चैप्टर्स हम लोग देखेंगे, मतलब अल्कोहल देखेंगे, एल्डिहाइड कीटोन्स देखेंगे, नाइट्रोजन कंपाउंड्स देखेंगे, सारे जो फिजिकल प्रॉपर्टीज व्हेन वी विल गो थ्रू इट, जब हम फिजिकल प्रॉपर्टीज के साथ देखेंगे वहां पे हाइड्रोजन बॉन्डिंग विल बी आवर मेजर थिंग ऑफ डिस्कशन. बॉइलिंग पॉइंट, मेल्टिंग पॉइंट, सॉल्युबिलिटी, ऐसे सारे जो क्वेश्चंस आते हैं जिसमें हाइड्रोजन बॉन्डिंग इज गोना प्ले अ वाइटल रोल, एंड यू नो दैट ऐसे टाइप के क्वेश्चंस बहुत ज्यादा आते हैं, है ना. नाउ, सो ऑल द फिजिकल प्रॉपर्टीज ऑफ ऑल द 3 chapters. Apart from that, बायोमोलिक्यूल्स में भी इसके क्वेश्चंस किए जा सकते हैं. हम लोग अगर going to release, we are going to release the part 2 also going forward. अगर हम लोग आगे की जो हाइड्रोजन बॉन्डिंग के टॉपिक्स में देखेंगे, वहां पे हम लोग देखेंगे कि इस particularly from hydrogen bonding there can be much more elevated topics can also be discussed, like for example overpotential. In electrochemistry we have heard about overpotential, right? वहां पे भी hydrogen bonding is the major thing which is playing the role. So without any further ado, let's just jump into the topic. कैसे हम लोग solutions की and as well as all the physical properties related questions, how can we cover them up? ठीक है? तो first, before I get started with the questions, I know many of you are not really thorough or not really clear with hydrogen bonding. So let me talk about what is hydrogen bonding first, okay? Now, so I will be quickly going over it. So you can see, this is the periodic table for you, right? This is the entire periodic table for you. In the periodic table, जब हमने periodic table जो chapter हमने किया था, वहां पे हम लोगों ने electronegativity, we learned a topic called electronegativity, right? So I hope you remember what is electronegativity. So let me give you a small example of electronegativity over here. Let's say this is me and I am playing a tug of war with you. Okay. So we are playing tug of war with each other. So in tug of war, what happens? There is a, let's say there is a flag in between. Okay? There is a flag in between. Now let's say you are more powerful than me. Let's say you have muscles over here. So you are more powerful than me. Then what will happen? Let's say this is the rope, tie rope. Tie line, what I meant is. Now what will happen? You will drag this rope more towards you, isn't it? So now what will happen? So this particular flag will move a little bit towards you. This is what electronegativity is all about. What happens is, in the entire periodic table, if you just notice these three people, N, O and F, these three are the top 3 electronegative element. They are the top 3 electronegative element. So going forward, आगे भी हम लोगों को याद रखना है FON के बारे में. FON, FON. We will always remember about FON. FON are the top 3 electronegative element. Fluorine is the highest, then oxygen, then nitrogen. So these are the 3 topmost electronegative element. They are the top 3 electronegative element. Okay. So about these top 3 electronegative element only, what we are going to see is, we see hydrogen bonding for FON only. We see hydrogen bonding for FON people only. Okay. I guess it is visible. It is 3 I have written. Okay. Now, whenever we are talking about the hydrogen bonding, we are talking about the FON elements only. Now, if you notice what happens in hydrogen bonding, see what happens for FON people. If I talk about that first, see this powerful guy, in this example you are the powerful guy, right? So this FON are actually the powerful guys of periodic table. Yes or no? FON are the powerful people of periodic table, right? Now, if that happens, in that case, if one of the 3 topmost powerful people, then what will happen? Let's say I am making, I need some space. Just a second. Okay. Let's say I'm going to use this part. Let's say I am making this particular bond, HF. Let's take HF for an example. If I'm taking HF for an example here, as FON is a very, very electronegative element, what will it do? See, particularly all the covalent bonds are made up of electrons. We all know that. All the covalent bonds are made up of how many electrons, guys? Can I just pause this video and give it a try? Very good. It's made up of 2 electrons, right? So this FON element, what will they do? Let's say these are the 2 electrons I have drawn. What will this FON do? It will drag the 2 electrons towards itself. It will drag the 2 electrons towards itself, right? Because it is more electronegative. As a result, what will happen? As a result, this fluorine will have delta negative charge and the hydrogen will have delta positive charge. होता है ना, जब हम लोग कोई गेम जीत रहे होते हैं तो we start feeling happy, isn't it? This is the same thing. So when the fluorine is dragging the electrons towards itself, what will happen? The electrons are negatively charged. So if the electrons are negatively charged, the fluorine will feel negative because the electrons are coming towards them. That's why delta negative. What is delta? Delta means just a little bit of charge separation, right? And this will turn into delta positive. Okay, delta positive, why? Because it is losing, right? So this is how the separation happens, and this is called dipole, guys. What do we call this? We call this a dipole. Okay, yes, we call it a dipole, right? So if this is a dipole and if the charge separation happens, from here the hydrogen bonding comes into the picture. Now what is hydrogen bonding? Let's say I have another HF molecule. Okay, this is one HF molecule. This is another HF molecule. I have 2 HF molecules over here. So in the other HF molecule also, यहाँ पे भी क्या हो जाएगा? ऐसे charge separation हो जाएगा. Delta minus towards fluorine, delta plus towards hydrogen. क्यों हो रहा है ऐसा? क्योंकि fluorine is more electronegative, है ना? Electron cloud will shift towards fluorine there. This much we are clear, everyone? Very good. Now, see. So this is also a dipole, right, guys? This is also a dipole. Now between these 2 dipole, if you notice here, guys, pay attention now. If you notice here, this is minus charge and this is plus charge, right? Opposite charges will, very good, attract each other. So because of that, here there will be a force of attraction getting generated. Yes or no? There will be a force of attraction getting generated between plus and minus. And because of that reason, we will call it hydrogen bonding. So what is the moral of the story? Moral of the story क्या है? Moral of the story is, between 2 dipole, when you have FON molecule present in it, when you have FON present in it, in that situation only, between two dipole, the force which is formed, the force of attraction which is formed, that is called hydrogen bonding. So hydrogen bonding को हम लोग क्या बोल सकते, इसको हम लोग एक inter after that molecular, इसको हम एक intermolecular force भी बोल सकते हैं. We can call it a intermolecular force also, right? So it is an intermolecular force, hydrogen bonding is. Going forward, I will tell you what all other types of hydrogen bondings are there. I'm not saying that hydrogen bonding is specifically intermolecular. It can be intramolecular also. I'm going to talk about that. But right now, for the first time when we are learning, we should go for intermolecular hydrogen bonding only. Okay. Now, so this is the entire picture of it. Now, let's dig deep into it. कि hydrogen bonding का और क्या like what all other variations can we have about hydrogen bonding. Okay. So I'm going to rub it off. Okay. If you feel you know all these things, you can definitely skip this part and go to the question part, okay? Directly. Now, anyway, let's get top. I guess the yellow is better visible now. Okay. Now listen up. That means, what is the moral of the story? Moral of the story क्या है यहाँ पे? Moral of the story is, when you have a hydrogen, okay. Moral of the story is, when you have a hydrogen connected to one of the FON molecule, it can be anybody. It can be fluorine, it can be oxygen, it can be nitrogen. So let's do one thing now. Rather than calling it FON all the time, let's call it atom A. Okay. Okay. This atom A has to be one of the FON elements. Okay. FON. Only then hydrogen bonding will happen, guys. FON. If FON is present, only then hydrogen bonding will happen. Now this is connected to another element. Let's say B. B will also be FON. B will also be an FON element. Only then hydrogen bonding can happen. Okay, how? I'm going to tell you how. See, when we talk about hydrogen bonding, when we talk about hydrogen bonding, what did I teach you right now? मैंने क्या पढ़ा है अभी? Whenever we have FON elements are connected, they are electronegative, so they will drag the electron cloud towards themselves, so it will become delta minus and the hydrogen will become delta plus, right? The charge separation is clear to us. Now, B, it's an electronegative element itself, so it will always be delta minus, right? Who are the delta minus elements? Whoever are electronegative, they are a delta minus, no? FON are delta minus all the time, right? So considering that, what will happen is now, in between them, the interaction will get formed. That is called hydrogen bonding. So for hydrogen bonding, the generalized version is AHB. Just remember this particular situation. AHB. So you have AHB, where A has to be a FON element and B also have to be a FON element. Both of them has to be FON elements. So there should be two FONs, okay? And one FON is connected to the hydrogen and the other FON is attracting it. Two of the FONs are needed, okay? Whoever contains the hydrogen, that particular element means AH. This AH is called hydrogen donor. I will talk about this more going forward. Whoever is containing the hydrogen, that is called hydrogen bond donor, and whoever is attracting the hydrogen, that is called hydrogen bond acceptor. Okay, there is a donor, there is an acceptor. So hydrogen bond donor will be whoever is having the hydrogen, and hydrogen bond acceptor will be whoever is attracting the hydrogen. Okay, so this is the moral of the story. Okay, now, so there is a picture over here. Let's look into this picture now. ठीक है, इस picture को देखते हैं अभी. अब इस picture में हमें पता लगाना है कि hydrogen bonding, whatever we have understood, whether it is following that or not. अच्छा, first of all हमने क्या बताया? यहाँ पे A HB, ये वाला situation हमें हमेशा we have to keep in mind. AHB, correct? So now, let's see whether that is being followed or not. See, they are writing ROH. They are writing ROH. So ROH is a kind of an alcohol, where R group can be any alkyl group, correct? That is what ROH is. Now, you can see we have the Fon elements over here. Do you see this? Oxygen over here. This is one of the Fon element. This is another Fon element, and this is my hydrogen. Can you see this thing? A, H, B. A has to be a Fon, B has to be a Fon. Now what will happen? If I see this, what will happen here? Let me change the color. See, out of oxygen and hydrogen, guys, pause the video and try it out first on your own, okay? Then watch it again. Now see, out of H and O, who is more electronegative? Oxygen is. So oxygen will be dragging the electron cloud, right? If oxygen drags the electron cloud, what will be the charge on oxygen, guys? Delta positive, right? The charge on oxygen will be delta positive, right? Wrong. It will be delta negative. Those who were nodding heads, they were all wrong. It will be delta negative, right, guys? And this will be, hydrogen will be delta positive. This much we are clear. Now, similarly, what will be the charge on oxygen over here? Again, delta negative, because it is electronegative element. So it will be dragging the electron cloud from this hydrogen. So this will be delta negative, this will be delta positive. So between this delta negative and this delta positive, the interaction which is being formed, that is called hydrogen bonding. So this is a very good example of hydrogen bonding, isn't it, guys? Are we understanding this thing now? Right? Okay, we'll see some applications of this. Now, question is hydrogen bonding only homoatomic, or it can be heteroatomic also? What do I mean by this question? See, let's say I am taking an example. Let's say I'm taking the example of water. I'm taking the example of water molecule. This is water molecule, guys. Now, question is, can it show hydrogen bonding? And if it can show, how many can it show hydrogen bonding? See, water has 2 lone pairs present in it. I guess we all know that water has 2 lone pairs present in it. Okay. If water has 2 lone pairs present in it, then in that case, how many hydrogen bonding is it capable of showing? Okay. How many hydrogen bonding centers do we have? So this is the most important part of the video, guys. So if you are watching till now, and if you're feeling like, sir, the thing is very difficult and all, stay with me now. This is the most important part of the video. Okay. If you understand this part, then your entire hydrogen bonding will be clear. Okay. Now listen up. How many total centers are there? Let's solve this question. How many total centers are there? Total centers for what? Total centers of H bonding. Means my question is, total कितना hydrogen bonding हम लोग यहाँ पे बना सकेंगे? How many hydrogen bonding can we make totally? Okay. Now, let's try it out. See, if I consider this guy as my A, okay, consider this guy as my A, then this will be your H. So this is my A, this is my H. Okay. If I draw a water molecule now beneath it, let's say in the same way, ऐसे अगर हम लोग draw करते इस चीज को. Okay, listen up. This is very, very important, guys. If this is my A, if this is my H, this is my B. Right, guys? A is also Fon, which is oxygen, hydrogen, then B is also Fon. So this is my B. Can we understand this? Can we understand this, guys? So this is my first site, which is from here. There will be one hydrogen bonding. Okay. Can you try it out, guys? Can you try out? Is there any other site of hydrogen bonding which is there in this molecule? Give it a try. Pause this video and try to tell me how many total hydrogen bonding sites will be there. See, I'm going to tell you another one. This is A. Look at the other side. This is H. Now, if I draw another water molecule down there, then this will be another hydrogen bonding. See, A, H, B. This is my A, this is my H, this is my B. So this is another hydrogen bonding site. Are we understanding it now, guys? This is my another hydrogen bonding site. Okay. Now let's try out if we have any more hydrogen bonding site over here or not. Okay. All right. So guys, similar way, just the way I have drawn these two, similarly, I can draw two more. Where? See, this is the lone pair of oxygen. From here, I can make a hydrogen bonding with a hydrogen of another water molecule. And from here, I can make a hydrogen bonding from the hydrogen of another water molecule. So how many total hydrogen bonding water is capable of making, guys? It can make total 4 hydrogen bonding. It makes a tetrahedral hydrogen bonding site. That is why ice floats on water. Okay. So any which ways, coming back to the point, guys. So total how many hydrogen bonding water can make? 4. We will see these kind of questions even more going forward. Okay. Now the next question that comes is, I have shown only water molecule, correct? This is also water molecule, this is also water molecule, this is also water molecule, this is also. All of them are water, right? Question is, do we always have to have water? Or can we have a water on some other molecule also? Can we make hydrogen bonding between 2 different molecules? Means, can we make a hydrogen bonding between a water and ammonia molecule? Is it possible? Okay, think about this. In the meanwhile, I'll just rub this part off. So, is hydrogen bonding only between the same molecules? Can we do it in between 2 different molecules also? If you look at the pictures, guys, the answer is right there. If you look at the pictures. So what do you see in the picture? See, the first picture is showing you how the water molecules are going to be making hydrogen bonding. Okay. How many total I said? Total will be there 4, right? There will be total 4 hydrogen bonding happening there. Now, similarly, if you see the structure down below, if you see the second picture, while I'm rubbing it off, guys, quickly have a look into the second picture. In the second picture, you can clearly see what is happening there, guys. There is one water, one ammonia molecule. See, I have to just check whether I have the FON, I have the AHB thing, or whether I have FON there or not, right? That is my target to check. Now, if you notice, see, this is my A, which is one of the FON elements, oxygen is present. This is my hydrogen, right? And this is my B. So I have A, H, B. Now, in here, B will be having delta negative charge. Hydrogen is delta positive, oxygen is delta negative. So there will be the hydrogen bonding here. So see, this is my AHB thing. Check here. So wherever you find this AHB, you will always remember that this can show hydrogen bonding. Is it clear to all of us? All right, very good, very good. Now, so guys, that means hydrogen band bonding can be between 2 same molecules. It can be between 2 different molecules. Okay, let me give you one more example. Are we up for one more example here? See, let's say I have, let's take, okay, you tell me an example here. See, I have made a question with oxygen. I have made a question with nitrogen. Who is left? Fluorine, right? So we are going to make one question with fluorine. Let's say I'm making water here, H2, right? I can write H2 in this way. And let's say I'm writing the other molecule as HF. I'll be writing. I'll be drawing HF. So HF. Okay. Will it show hydrogen bonding, guys? Pause the video and try to tell me whether it will show hydrogen bonding or not. All right. I guess all of you have tried this. See now. Do you see AHB situation? See, A is oxygen, H, B. Correct? A and B has to be FON elements. Correct? So this is also hydrogen bonding, right? This is where the hydrogen bonding will form. If you want to see the charge separation, this is how it is. The oxygen will be dragging the electron. Charge, guys. Come on, say it. Delta plus or delta minus? Delta minus. Very good. Delta plus, delta minus. Like this, we will be able to make the hydrogen bonding. Right, guys? Now, the next question that we are going to go for is, so hydrogen bonding can happen between same type of molecules. It can be happening between different types of molecules. Let's go to the next slide now. So the question was, is hydrogen bonding only intermolecular? See guys, so far, till now, we were making hydrogen bonding between 2 molecules. This is one molecule, this is the other molecule. We have been showing hydrogen bonding between 2 molecules only, right? 2 different molecules we have been always checking. But is it always has to be between 2 molecules? I have made you write that hydrogen bonding is intermolecular. intermolecular. This is what you have written already. Hydrogen bonding is intermolecular, right? But does it always has to be intermolecular, or is there any chances that it can be intramolecular also? So guys, that is the answer I'm going to give you here. If you remember, in the beginning of the class only, I've been telling you that hydrogen bonding is between two molecules. If you just notice over here, the previous question over here, that over here, you can see this is water is one molecule and this water is another molecule. And between two molecules, this hydrogen bonding is happening. So this is going to be called as intermolecular hydrogen bonding. But do we always need to have two different molecules in this case, guys? So for that, let's see for the next question. Here, the question is the same. Is hydrogen bonding only intermolecular? Can there be any intramolecular hydrogen bonding as well? That is the answer we are trying to find out. This is the molecule. I guess you have seen it. This molecule is called orthonitrophenol. Can you tell me, guys, what is the most famous question comes from this particular molecule? Almost in every alternate year this question has come. That question is about the boiling point. Remember that? Orthonitrophenol versus paranitrophenol, who has the higher boiling point, or how can you separate out ortho and paranitrophenol? That question can also be solved by hydrogen bonding only. Is there anyone who knows the answer? How can we separate out ortho and paranitrophenol? Ortho, nitro and paranitrophenol. Anybody? The answer will be steam distillation. Very good, guys. Now, any which ways, why the steam distillation was the answer to that question? Because if you notice, in this molecule also, this is my A, this is my hydrogen, and this is my B, correct? So in here also there will be a hydrogen bonding happening. There also it will be hydrogen bonding. But will it be like the previous hydrogen bonding, guys? In previous hydrogen bonding, we used to draw two different molecules all the time. But here I'm drawing just one molecule. So what kind of hydrogen bonding will it be? This will be called, see, as you can see that this hydrogen bonding is happening between inside the same molecule only, right? I understand that between the two groups, but these two groups are a part of the same molecule. So can't we say that this is intramolecular hydrogen bonding, right, guys? So this will be your intramolecular hydrogen bonding. So hydrogen bonding can be intermolecular, it can be intramolecular also. Okay. Now, based on that, let's try out some questions in here. Okay. Before we start this previous year question, this question is only from 2025. Okay, I told you in 2025 there were multiple questions which covers up hydrogen bonding. So first we need to understand which questions are of hydrogen bonding question. Means when to understand that, okay, this question can be solved by hydrogen bonding. So for that I'm going to give you a trick. See, whenever you see a question regarding basicity or solubility, whenever you see a question coming from basicity or solubility, see, basicity I'm going to come later. That is a chemical property. But what is solubility? That's a physical property, right? So whenever we see physical property question, I told you guys what happens in physical property questions. Whenever we see physical property questions, there, if it is haloalkane haloarenes, if it is the first chapter, then leave it. But if it is from the second chapter, means second to fourth, means alcohol phenol ethers, aldehyde ketone carboxylic acid, and the amines. For these three chapters, guys, you will always run towards hydrogen bonding. That's a shortcut. Okay. See, from which chapter is this question coming from? From the fourth chapter, amines, because nitrogens are there, na? Nitrogenous compound. Pardon me for saying amines. So इसको हम बोलते हैं nitrogenous compounds, है ना? So nitrogenous compounds से ये question आया. So definitely it is gonna be your hydrogen bonding question. Clear? So we are gonna try this third question first, and then we are gonna try the second question. Okay? So in the third question, they are saying ethylamine is soluble in water, whereas aniline is insoluble. That means, guys, by the way, one more thing, how to understand if the question is physical property or not. Many of you might be thinking that also, that sir, we don't even know what is a physical property question and what's a chemical property question, right? So I'm going to talk about that now. See, how to understand the physical property question. Whenever the question comes from basic, what do we call that? Boiling point and melting point, right? Whenever the question comes from boiling point and melting point, in these two questions, these two types of questions, this will be physical property, correct? Whenever they talk about solubility, that is also physical property question. So boiling point, melting point, solubility. These are the three types of question that comes under your physical property, correct? So whenever you see these kind of question, this will be hydrogen bonding. See, ethylamine is soluble in water, whereas aniline is insoluble in water. So how can you solve this question? So I'm going to rub this part off first. See now. Let's say we talk about ethylamine. So how will the ethylamine look like, guys? Ethyl means what? How many carbons are there? 2, na? So I'm going to draw CH3, CH2, that is your ethyl, and amine. Now, while drawing amine, what I'm going to do is, I'm going to flare out the hydrogens, as you can see. Okay. Can you pause the video and can you tell me whether nitrogen has any lone pair or not? See, for water we have seen, na? Oxygen has 2 lone pairs. I always say oxygen looks like Mickey Mouse. Let me show you how. If this is oxygen, oxygen has 2 lone pairs, right? Like this. So I can draw a Mickey Mouse out of it. Okay. Anyways, guys. So can you tell me how many lone pairs, and if there are any lone pairs are there in nitrogen or not? Pause the video and give it a try. So I hope all of you found it. There is a lone pair. Now guys, again, try. How many hydrogen bonding sites are present for this molecule? For this molecule, how many hydrogen bonding sites are present? How many total hydrogen bonding can this molecule do? The answer is, see, one will be A, H, B. So if I have a B element in there, it will form hydrogen bonding. They are talking about solubility in water. So what is the B element, guys? The B element will be water. Simple, no? If this is a solubility question, always take water. Okay? Solubility in water. So I have the B element here. So this is one hydrogen bonding. How many more? Again, another hydrogen bonding will be from here. Right? I hope you can identify the AHB thing. Right, guys? यहाँ पे A मिल रहा है हमें, यहाँ पे H मिल रहा है हमें, यहाँ पे B मिल रहा है ना? ये रहा हमारा AHB. A और B दोनों को फॉन बनना है. I guess you remember that. Both of them has to be fon, right? यहाँ पे भी एक AHB बन रहा है. Can you see that? This is my A, this is H, and this is my B. Correct? So these are 2 hydrogen bonding. One more hydrogen bonding will happen from the lone pair side. Just the same way we have seen in water molecules, right? The same way. One side will be in water also 2 lone pairs were there, no? From the 2 lone pairs we saw 2 hydrogen bonding happening. So similarly here also there will be 1 hydrogen bonding from the lone pair side. Can you pause the video and can you try it, guys? We are trying to make it more interactive, right? I know that whenever we are watching online classes, the classes are not much interactive that they say, right? But we will try to make it more interactive, guys. So give it a try. Pause the video and tell me, if I make a hydrogen bonding from the lone pair side, who will it be making hydrogen bond with? What part of water molecule? See, right now, the hydrogens are making the hydrogen bonding with the oxygen part, no? So who will be here in the water molecule? Here it will be hydrogen, correct, guys? So if I draw the water molecule here, so here it will be hydrogen. From which side the hydrogen bonding will happen? So far I believe we are clear. So ethylamine can form how many hydrogen bonding? The answer is 3. Total 3 hydrogen bonding and ethylamine molecule is capable of forming. This much we are all clear. Now, what will happen for aniline now? So I'm going to just go to the next slide rather. अभी हम अगर aniline को लेके चलते हैं यहाँ पे. If we have aniline over here, okay, come on, give it a try. How many hydrogen bonding can aniline make with? Who is it making with? With, guys, it is making with water only, right? So how many total hydrogen bonding it can make? Give it a try, guys. Pause this video and give it a try. See, one will be with the hydrogen site here, correct? Can you tell me where else? If this is your A, this is your H, this is your B, where else can I make AHB situation? On the other side also. There also there can be a water molecule here. Are we getting this? There will be another hydrogen bonding here. Where else, guys? With the lone pair on the top also. Isn't it? Total how many hydrogen bonding? 3. So in ethylamine also, we had how many hydrogen bonding? 3. And in aniline also how many hydrogen bonding? 3 only. So in both the cases, we have 3 hydrogen bonding, correct? Okay. Now, if both of them has 3 hydrogen bonding, then what is the verdict? If both of them has 3 hydrogen bonding, then what is the verdict? See, more you make hydrogen bonding, what happens there? Let's say right now you are at home, correct? You are interacting with me right now, okay? Let's say when you go to play outside, what happens? You feel more fun there, right? Right now you're watching this video because your exams are coming out, isn't it? But generally when you go outside to play with your friends, you feel much more comfortable there. Why? Because you interact with them better than the way you're interacting with me, correct? So right now if I give you 2 choices, either one, you can stay here in InSmart and you can watch videos throughout the day, versus you can go out and play with your friends. What will you do? You'll go out and play with your friends, right? So why will you do that? Because there you are much more attracted, you are much more interacting there than over here, right? Definitely, I know that you won't lie to me here, but that is the thing that you will do, right? Everyone will do that. Even I would have done that, correct? So now coming to the point, guys, here, whenever a molecule, let's say this pen is my molecule, if it is interacting with water, then it will be soluble in water. See, this ethylamine is making hydrogen bonding with water. That means it is interacting. If it is interacting, it will be soluble in water. So ethylamine is soluble in water. So by the same logic, this will also be soluble in water. So I'm going to just write it down first. So when, this is the last question of this video, guys. In the next video, we will be solving the rest of the questions. When there is hydrogen bonding, guys, this topic is very, very important for us. When there is hydrogen bonding between, a solute, I hope we know what is a solute. I'm going to tell you anyway. When there is a hydrogen bonding between a solute and a solvent, if there is hydrogen bonding, then what is the verdict, guys? What is the result then? There will be a solution. So what is the criteria of solution? What is the criteria of dissolution? The dissolution's criteria is when the solute and solvent are interacting, means hydrogen bonding are there. So it will be soluble. They say that oil doesn't dissolve in water. Why? Because oil doesn't make hydrogen bonding with water. But in the other hand, if I take glucose and if I put it in water, glucose will make hydrogen bonding with water. So that's why glucose is soluble. Oil is not soluble, correct? Now, over here also we are going to see that this ethylamine is making hydrogen bonding with water. How many, guys? 3 hydrogen bonding. So it will be soluble in water. Using the same concept, I could have said that aniline will also be soluble in water. No, it is making 3 hydrogen bonding, so it should also be soluble in water. But there is a part, guys. Aniline, we see that it is insoluble in water. That is the question. Read the question once. Why ethylamine is soluble in water whereas aniline is insoluble? That's why this question is a difficult question. Because if you just know hydrogen bonding, you won't be able to solve the question, because you will feel like, sir, in both the cases there are hydrogen bonding happening. So why is aniline not soluble in water? So here's the part, guys. See, it is because of this benzene ring. What is wrong with the benzene ring, guys? See, in benzene ring, what happens is, this part is hydrophobic. This part is hydrophobic. Hydrophobic. I guess this handwriting won't be visible, so I'm gonna write down here. So this part is hydrophobic. Hydrophobic means what? Hydro means what? Water. Phobic comes from the word phobia. Phobia is the opposite of philia. Philia means love. Phobia, I guess we are aware of it, right, guys? Phobia means fear. Hydrophobic means who are afraid of water. So this benzene part, any carbon chains, whenever you see carbon chains are present, hydrocarbon chains are present, they are all hydrophobic. They are afraid of water. Oil is a long hydrocarbon chain, and that is why it's not soluble in water, because this is hydrophobic part. So as this benzene ring is a carbon chain, wherever we see carbon chain, they are hydrophobic in nature, and because of this benzene ring, because of this hydrophobic part, we see aniline is not soluble in water, or sparingly soluble in water. So it is not because of hydrogen bonding, guys. If it was hydrogen bonding, then both of them should have been soluble. That's why this question is special. Here, because of this hydrophobic part, this molecule is less soluble in water than ethylamine. The rest of the questions we will be solving in the next part. If you want to see this kind of videos, if you are feeling much more confident after watching this kind of video, guys, do go check out our app NSmart in the app stores. You can download them and you can have these kind of videos over there. So for today, we are gonna keep it up to this. We are gonna see in the next videos. See you then, guys. Bye, everyone.